teacher at any basis. Today, in our lesson, we are going to brainstorm and do a conclusion on rotations and reflections. So I want to mention that a special matrix of rotation is used when we have a center of rotation as the origin and the angle of rotation. This angle of rotation may be denoted as theta, alpha, beta, lambda, any other notation among others. And this special matrix of rotation is given by cos theta, sin theta, negative sin theta, cos theta, as you have this idea in your notes. That angle theta can be positive or negative. In this, I mentioned in your notes that the positive angle is said to be anti-clockwise and the negative angle is said to be clockwise. Anti-clockwise, clockwise. It's the sign. Positive is anti-clockwise, the negative is clockwise. These angles strictly can also be given as tans. Remember, in any circle, we have a complete revolution which kicks off at 0, and throughout the whole circle we reach 360. So in terms of tans, these are fractions of 360. Tans mean, for example, when you look at the 4 quadrants that make up a circle, there are 4. So 360 degrees divided by 4 gives us 90. Meaning 90 degrees, candidates, 90 degrees is a tan, which tan is a fraction. The fraction is a quarter of 360. That is to say, if someone says a quarter tan, if someone talks about a quarter tan, it implies that person is talking about a quarter times 360, implying the angle mentioned in this statement is 90 degrees. So if someone mentions a positive half turn, then that person is talking about a half times 360, which is 180. And on the circle here, 180 is reached at that horizontal position. So in your notes, look at the statements I made. You will discover all these issues are there. I want to summarize rotations by saying that what you need to note is that the leading diagonal in the special matrix of rotation comprises of cosines and the minor diagonal comprises of sines, whereby one of the signs is negative in the upper entry in that minor diagonal. Point noted, the center of rotation must be 0, 0. So just one example to summarize rotations. Just one example. Example, a point A of coordinates 1, 2 is rotated about 0, 0 through a negative quarter turn, comma, find the coordinates of a prime. Find the coordinates of a prime. Remember, we are under special matrices of transformation. We will still say that matrix of rotation, matrix of rotation times the object matrix gives us the image matrix. This gives us the image matrix. Matrix of rotation, remember it is cos theta, sin theta, negative sin theta, cos theta. Multiplied by the object matrix, which is A. The resultant will be the image matrix, which will be A prime. We know our A is 1, 2, and A prime is what we don't know. However, the angle of rotation, we have been told it is a negative quarter turn. And that means this will be negative 1/4 times the complete loop or revolution, which is 360. Ladies and gentlemen, this gives us negative 90 degrees. So that means the matrix of rotation will be, as we substitute cos of negative 90 degrees, sine of negative 90 degrees, negative sine of negative 90 degrees, and cos of negative 90 degrees. The matrix then becomes 0. If you check with your calculator, negative 1, 1, and 0. So that implies when you substitute in our previous stage, 0, negative 1 is the matrix, 1, 0, it hits A, which is 1, 2, and the resultant will be the image matrix A prime. And then here the process remains as we discussed earlier, row by column, and the resultant matrix will be for A prime, which helps you deduce the coordinates of A prime. That's what I wanted to mention